I am Kyle G.B. Alonzo, the first reporter of the Group 1, and our topic is all about binary operations. We are quite familiar with arithmetic operations like addition, subtraction, division, and multiplication. Also, we know about exponential function, log function, etc. Today, we will learn about the binary operations. As the name suggests, binary stands for 2. Does that mean that we can use two functions simultaneously using binary operation? Let's find out. So, a binary operation is a mathematical operation that takes in two inputs, known as operands, and uses them to produce a single output. The term binary indicates that there are exactly two operands involved. So, here are few examples. First is addition. When we add two numbers, such as 4 and 5, the binary operation of addition combines these two operands. The result in this case is 9. The plus symbol represents the binary operation of addition. Second is subtraction. Subtraction is another binary operation that takes two numbers and produces their difference. For instance, if we subtract 8 from 12, the binary operation of subtraction yields 4. The minus symbol represents the binary operation of subtraction. And lastly, division. Division is a binary operation that involves dividing one number, the divided by another, or the divisor to obtain the quotient. For instance, if we divide 15 by 3, the binary operation of division result is 5. The division symbol divided or divisor represent this operation. There are just a few basic examples of binary operations. In mathematics, there are many another binary operation used in various branches, such as matrix, multiplication, set operation like intersection and union, logical operation like and, or, and more. Binary operations often follow specific rules and properties. For example, addition is commutative. Open parenthesis a plus b is equals b plus a, close parenthesis, and associative, open parenthesis a plus b, close parenthesis, plus c is equals a plus open parenthesis b plus c, close parenthesis. But subtraction is not commutative. Open parenthesis a minus b, b minus a, close parenthesis. These properties help define the behavior and properties of binary operation.
So what is binary operation? Binary operations are mathematical that operations take two operands and produce a single result. So in mathematics, a binary operation or Jadik operation is a rule for combining two elements, which is called the operands, to produce another element. More formally, a binary operation is an operation of arity 2. So, they are commonly denoted by symbol, such as addition, subtraction, multiplication, division, and exponential. So, we have some important properties of binary operation. The number one is closure. Closure, a binary operation on a set, is said to be closed if combining any two elements for that set using the operation always result in an element that is within the set. For example, addition and multiplication are closed operation on the set of real numbers. The number 2 is associativity. An operation is associative if the grouping of the element does not affect the result. In other words, for any three elements, we represent the binary operation. For example, addition and multiplication are associative operation. The last one is what we call identity element. An identity element is an element in a set that, when combined any other element using the binary operation, leaves the other element unchanged. For example, identity element addition is 0, as a positive 0 equals A for any element A. Similarly, the identity element for multiplication is 1, excluding the number 0 in some cases, as x1 is equal to A for any element A.
Inverse element. The inverse element, often referred to as simply the inverse, is an element in mathematics that, when combined with another element using a specific operation. This concept is commonly used in algebraic structures such as groups, rings, and fields. For example, the inverse of a number x with respect to addition is negative x, as x plus negative x equals 0. This means for the inverse property of addition, the inverse of a number is the same number with the opposite sign. When adding a number and its inverse together, the inverse property of addition states that the sum will always be 0. Commutativity in mathematics refers to the property of certain operations that are order independent. In other words, the order in which you apply the operation to two elements does not affect the result. For example, A plus B equals B plus A times B equals B times A. Commutative property is applicable only for addition and multiplication processes because we can change the position or swap the numbers when adding and multiplying any two numbers.
There are various types of binary operations. Each with its own characteristic and properties are same commonly encountered types of binary operations. Number 1. Arithmetic operations. There are the fundamental operations used in arithmetic including additions, subtractions, multiplications, and division. Arithmetic operations are typically performed on numbers and follow specific rules and properties. Number 2. Logical operation. These operations are used in Boolean algebra and logic circuits. The most common logical operations are conjunctions, disjunctions, exclusive disjunctions, and implication. Logical operations often involve truth values or true or false and have specific truth tables indicating the outputs based on the input. Number 3. Comparison operations. These operations compare the values of two elements and return a Boolean result comparison. Operations include equality, inequality, greater than, less than, greater than or equal to, and less than or equal to. These operations are frequently used in programming and algorithms.
Set operation. These involve manipulating set using binary operations like union, intersection, set difference, and symmetric difference. These operations help combine, subtract, or compare elements between sets. Matrix operation. In linear algebra, binary operations are used for calculation on matrices. Some matrix operations include a matrix addition, matrix subtraction, matrix multiplication, and finding the matrix inverse. Function operation. Binary operation can be applied to function. For example, you can compose a function or perform a pointwise addition and multiplication. These operations provide a way to work with combined functions. So these are just a few examples of binary operations encountered in mathematics, computer science, and other fields. Each type of operation has its own rules, properties, and application depending on the context in which it is used.
Binary operations offer several benefits and advantages, making them valuable in a various discipline. In conclusion, binary operation of simplicity often see compatibility and compact representation of data. They form the basic for Boolean logic, play a fundamental role in the digital system, and have wide-ranging application across various disciplines. Understanding and utilizing binary operation facilitates effective problem solving and advancement in areas dependent of digital technology and mathematical reasoning.
Binary operations conclusion. In conclusion, binary operations are fundamental mathematical operations that combine two elements to produce a unique result. They possess important properties and find applications in various fields, including mathematics, computer science, and logic. Understanding binary operations is crucial for solving problems and advancing knowledge in these domains. That's the end of our presentation. We hope that you learned in binary operations that we discussed. Thank you for your attention, and we hope that you find our presentation insightful. Everyone, let's appreciate the beauty and importance of mathematics. That's all. Thank you.